Star args and star kwargs are some of the best features in Python as they allow us to create some pretty powerful and flexible functions. But to better understand how these work, we'll first have to understand two underlying concepts: packing and unpacking. Packing is the idea of taking in multiple independent objects and combining them into a single data structure. So an example of that would be to take in the integers 1, 2, and 3 and pack them all together into a single tuple containing all three integers. On the other hand, unpacking does the exact opposite. Taking in a single data structure hosting n objects, it unpacks them into n individual objects that are no longer related. So here, if we take in this tuple from earlier, unpacking would return three individual integer objects, 1, 2, and 3. So why did I teach you that? Because that's exactly what the star and star operators right here do. They simply pack and unpack objects, that's it. Let's take a look at some examples. Say we want to define a function, greetings, that takes as input a name and simply greets this person. Calling this function with a single argument works fine. But if I try to call this function with two arguments, this will naturally cause a type error, as our function is expecting to only take in one argument. Anything other than that will cause an error. Modifying the function's definition so that it can take in two arguments, name1 and name2, will work fine here, but will now constrain the function to only work when two arguments are provided as input and fail in all other scenarios. So it seems like a function is bound to only accepting a fixed number of arguments, which is specified when defining the function, right? While this is true in many programming languages, it doesn't have to be the case in Python. By inserting an asterisk before a parameter, this will allow our function to take as input a variable number of positional arguments, which will all be packed into this single parameter. So here, let's name this parameter names and just print it. We'll try calling our function with 1, 2, and 3 arguments like so. Running the code, we can see that all calls executed successfully with no type errors. We can also observe that no matter how many arguments we sent to the function, all of them got packed into this single names parameter, which turns out to be a tuple. And now that we have access to such a tuple, we can easily loop over the names and greet each individual person. And here you go. How cool is that? Did you notice that I didn't use the name args? The star operator is what's actually doing all the work of packing these arguments into this parameter. The name of the parameter can be whatever you want. Args is simply a conventional name we use for a parameter that packs a variable number of positional arguments. Positional arguments, also called non-keyword arguments, are arguments that are just objects with no names attached to them. So they are assigned to parameters based on their positions. For instance, if we have a function add that takes in a and b, if we simply call add of 5, 10, 5 will be assigned to a and 10 to b given their position in the function call. Here, all of these arguments are positional, so perfect candidates to be packed in a tuple by the star operator. Oh, and one more important precision is that this names parameter will only pack all the unassigned positional arguments. If, for instance, this function needs to also take in a custom greeting, the first positional argument will be assigned to that parameter and then all the rest packed into the parameter preceded with the star operator. So here, to properly call this function, we will set our first argument to howdy, which will be assigned to custom greeting, followed by these names, which will all be packed into a single tuple assigned to names. And there you go. The double star operator works the same way but on keyword arguments. These are arguments that have a name attached to them. Here we have a function that takes in a user's first and last name and prints them out. If we call this function like this, or like this, both result in the same output. That's because keyword arguments don't care about position. Say here we also want to take in an unknown set of information about this user to print them out. And we want to provide this info in the form of keyword arguments. So we want to be able to call our function like this, or like this, and have both calls succeed. That's where the double asterisks come into play. By specifying that our function also takes in star star info, this will enable this function to pack all the passed and unassigned keyword arguments into this info parameter, which if we try to print, we will notice that it's naturally a dictionary to preserve this key value structure of keyword arguments. Once again, kwargs is simply a conventional name for accepting a variable number of keyword arguments, but any other variable name can be used such as info. Now you might be thinking to yourself, can we combine both args and kwargs? Yes, you sure can. They actually shine the most when combined. Writing a function that accepts star args star star kwargs basically means that we can call this function with whatever combination and number of both positional and keyword arguments. This can be super useful in some applications, such as when writing a function that needs to call another function without necessarily knowing what arguments this other function accepts. In this way, we can simply take in arbitrary arguments, both positional and keyword arguments, and simply pass those down any other function. We will see this in more detail in a future video on decorators I'm working on, so make sure to subscribe and stay tuned. Up till now, we've only talked about packing, but get ready to be blown away with unpacking. Going back to this function, taking in a person's first and last name to print them out, say we have our user data stored in a dictionary like so. How would you call this function with the user's data? Well, what most developers would do is set the first name parameter equal to user.firstname and last name equal to user.lastname. While this works fine, there's a much better alternative, which is to simply send star star user. This will effectively do the opposite of what we've seen before. It will unpack this dictionary into individual keyword arguments. So these two lines are 100% equivalent, and here is the output from both calls. Tell me that isn't cool. Here's another example. We have a list containing 3 strings, and printing this list produces the following output. But if we pass to the print function star list, this will effectively unpack all of these strings into individual positional arguments. So these two lines are 100% equivalent, and we'll verify that by running the code, and here's how the values are now printed. Keep on learning by clicking on one of these videos, and as always, don't forget to like if you want to learn even more Python.